Oh no, students! Elliot made a mistake. He forgot to do all of the examples today, so now I have to do a two-part lesson. I forgot, like, we did graph to equation, but I never did a table to equation problem. So let's do this table to equation. Now, one thing about a table to equation is that if looking at a table is your weakness, simply put this parabola or these points on graph paper, connect the dots, and now you have a graph to equation problem, which you can always do. So if you liked the graph to equation, you don't want to deal with table, just graph the table, and now you're a graph to equation. Yeah, like I said. But I'm here to teach you how to solve this problem using just the table. One thing to remember is that in a parabola, the parabola is always balanced on the left and the right side. That if this coordinate is at 0, 3, or 0, 0, say, and this coordinate is at 2, 4, because of the symmetric nature of the parabola, this point over here would be negative 2, positive 4. They'd have the exact same y coordinate. So what I notice is these 2 points have the same y coordinate. Those two. And then these 2 points have the same y coordinate. Then these 2 points have the same y coordinate. And then it meets right here in the middle with this y coordinate that's all by itself. And that's kind of like the vertex. The vertex is the only point that does not have a matching y. So just by looking at this table, I'm able to determine that this point is the vertex. So if I was going to do this problem in vertex form, I would have y equals a times x minus h quantity squared plus k, and I know h and k is negative 1 and negative 9, so here would be plus 1 quantity squared minus 9, and that's my h and my k. I'm looking for the a, and then I can plug any one of these coordinates into the equation, and as I look through these coordinates, this coordinate right here, 2, 0, that looks like the very easiest coordinate to deal with, so I'm going to change the y to a 0 and the x to a 2. So I located the vertex, plugged the vertex into the formula, and then I located any other coordinate and I put that coordinate into this equation. Now I'm going to algebraically solve for a. I'd add 9 to both sides, so 9 equals 2 plus 1 is 3. 3 squared is 9, so I have 9a. Whoa, that means a must be equal to 1. So my vertex form equation is y equals 1 parentheses x plus 1 quantity squared minus 9. And they're going to ask you after that to change it into standard form. So first you square the x plus 1. So you end up with x squared plus 2x plus 1 minus 9, which gives you a final answer of x squared plus 2x minus 8. Vertex form, standard form. You could also do this problem using factored form. Because when I look at this table, if I didn't notice the vertex, I do notice that these are the x-intercepts. That is when y is 0. The x-intercepts there and there. So factored form, y equals a parentheses x minus c1, x minus c2. And then I need to also plug in another point. I'm going to plug in this point. I don't know. I can't use 2, 0 now like I used it in vertex form because I'm using it as an x-intercept. So I need to pick a third point. I'm going to use 1, negative 5. So let's see. The y coordinate's negative 5 equals a. The x coordinate's 1. One of the x-intercepts is -4, so I'd put +4 here, and then x is 1, and the other x-intercept is 2. So I end up with -5 equals a times 5 times -1. So I get -5 equals -5a, and when I divide both sides by -5, I get a value of 1. Oops, I laid that out. So sorry about that. Plugged in all my coordinates. I don't know what people saw and didn't see in the last minute. I feel I need to talk through the problem again. I took my x coordinate, what am I looking? Not this. I plugged in my x-intercepts into this equation for C1 and C2, and then I plugged in this point 1, -5 in for x and y. And then I algebraically solved for a, and I ultimately got an answer of 1, which, because I got a 1 over here in vertex form, of course I must get a 1 in factored form, because a is always going to be the same value no matter what. So I have 1 times x plus 4 times x minus 2, and that is my factored form equation. And then if I multiplied them out to get to my standard form, I get x squared plus 4x minus 2x, so that's plus 2x, and then minus 8. So I have my factored form answer, my standard form answer, but of course my standard form answer would be identical here and here because we were working off the exact same table. Alright everybody, thank you for watching part 2 of today's lesson, which was called Table 2 Equation. I hope you're having yourself a great day, and I'll talk to you later. Bye-bye.